Space is vast in a way our human senses cannot easily understand. On Earth, distance is familiar, a walk across a room, a drive across a city, a flight across an ocean. But the moment we step beyond our planet, ordinary measures start to break down. Even the distances inside our own solar system stretch beyond anything we experience in daily life. To understand space, we must learn new units, new scales, and a new sense of size. The closest major object to Earth is the Moon. On average, it orbits Earth about 384,000 kilometers away, far enough that a jet would need nearly 3 weeks to reach it, but close enough that light covers the distance in just over 1 second. When we look at the Moon in the night sky, we are seeing it as it appeared a second ago. In space, even the nearest things take time to reach our eyes. Farther out is the Sun, our central star. It is about 150 million kilometers away, a distance so large that astronomers created a special unit to describe it, astronomical unit, or AU in short. 1 AU is the average distance between Earth and the Sun. It takes sunlight about 8 minutes to reach us, meaning every sunrise is 8 minutes old by the time we see it. This delay is small, but it marks the beginning of a strange truth. In space, the farther we look, the farther back in time we see. Using astronomical unit, we can start to map the solar system. Mercury orbits at about 0.4 astronomical units from the Sun, followed by Venus at 0.7. Earth is at 1 astronomical unit, and Mars at about 1.5. Beyond Mars, the spacing begins to widen dramatically. Jupiter, the first of the giant planets, orbits at roughly 5.2, already more than 5 times Earth's distance. Farther out, Saturn appears at about 9.5 astronomical units. Uranus orbits at 19, and Neptune, the most distant major planet, circles the Sun at roughly 30 astronomical units. Beyond Neptune, the distances grow even more dramatic. The Kuiper belt extends from about 30 to 50 astronomical units, filled with icy bodies and dwarf planets. But the edge of the Sun's influence, the distant Oort cloud, may begin thousands of astronomical units from the Sun and stretch tens of thousands more. Even at the speed of our fastest spacecraft, reaching those distances would take tens of thousands of years. One spacecraft is making that journey now. Voyager 1, launched in 1977, is more than 160 astronomical units from Earth. Its radio signals, traveling at the speed of light, take over 22 hours to reach us. The spacecraft itself moves at about 17 kilometers per second, incredibly fast by human standards, yet barely crawling through the vastness between stars. At these distances, even kilometers and AU become unwieldy. To describe the space between stars, astronomers use light years, the distance light travels in 1 year. Nothing moves faster than light, so a light year is not a measure of time, but of speed multiplied by time. About 9.46 trillion kilometers. The nearest star beyond the Sun is Proxima Centauri, a small red dwarf about 4.24 light-years away. If Earth were the size of a marble, Proxima Centauri would be another marble tens of thousands of kilometers away. With current technology, a spacecraft would need tens of thousands of years to reach it. Yet its light, moving at nearly 300,000 kilometers per second, takes a little over 4 years to arrive. When we look at this star through a telescope, we are not seeing it as it is now, but as it was 4 years ago. Telescopes do not shorten the travel time of light, they only collect more of it. A telescope cannot let us see the present. It only sharpens our view of the past. Beyond the nearest stars, we reach the Milky Way, our home galaxy, a vast, rotating system of hundreds of billions of stars. Earth orbits the Sun, but the Sun itself orbits the center of the galaxy at a distance of about 26,000 light-years. The Milky Way is roughly 100,000 light-years across. Light from one side takes 100 millennia to reach the other. When we observe distant regions of the galaxy, we see ancient light, some older than human civilization itself. Outside our galaxy, the distances grow even more extraordinary. The nearest large galaxy is Andromeda, about 2.5 million light-years away. When we look at it, we see a galaxy as it was long before early humans walked the Earth. And beyond Andromeda stretches the observable universe, containing trillions of galaxies across distances so extreme that even light-years are not enough. For the largest scales, astronomers use billions of light-years, or parsecs. At the farthest edges of what we can observe, light has traveled more than 13 billion years to reach us. We see galaxies not as they are today, but as they were when the universe was young. The night sky becomes a time machine, revealing ancient eras long vanished but still preserved in the light that left them. In space, distance and time are inseparable. The farther we look, the deeper into the past we peer. Every star, every galaxy, every faint glow in the darkness carries the story of how long its light has traveled to reach us. For humans, these scales are difficult to grasp, yet they offer perspective. Our solar system, enormous by everyday standards, is just a tiny neighborhood in the Milky Way. Our galaxy is only one among countless others in the observable universe. And yet, from this small world, the third planet from the Sun, we can measure the distances between stars, map the structure of galaxies, and look back to the dawn of time itself. Understanding space distances reminds us of both the enormity of the universe and the rarity of our place within it. The cosmos is vast beyond imagination, but through light, mathematics, and curiosity, we have found a way to measure its scale, one astronomical unit and one light-year at a time. Thanks for watching. You'll find all the space distances in the comments below.